Hey, g'day, it's Prezant. Thanks for stopping by. Now I'm working on the Stuart Turner 10H model steam engine today. This is episode 4. There's a playlist up above there now if you want to go back and look at the previous episodes. And today I'm going to try to key the flywheel onto the crankshaft. And I've got a special tool made up to use in the milling machine to do that. And then we're going to have a go at machining up the cylinder and the cylinder covers. Okay, it's time to shorten this crankshaft. So this end here is close to its correct length, but it needs to have a drilled and tapped hole in this end. And this one here is a lot longer than it needs to be. Now it's an awkward thing to machine. You can't put this end in a collet while you're trying to machine that because of the crank webs. And you really should be gripping it by the part that you're wanting to shorten. If I grip it back here and try and shorten this end here, the pressure of the cutting tool is likely to deflect the whole crankshaft and will bend at the crank pin. Now if you had a tiny little steady rest or a following rest, you could probably do it that way. But what I've done is I've made up this split aluminium bush here. I can slide that over the crankshaft and I can grip this in the 4-jaw chuck, and it doesn't have any effect on this crank web here. It's free to move inside the chuck, so that's not a problem. So I'll set this up. You do need to dial it in with an indicator, and then I've only got to take off about 1 millimeter at this end. So I'll do that one, and then you can imagine the other end is the same. And when you're doing this, you need to check that the crank web isn't touching the back of this jaw here. Yeah, I can see inside there, I know it's clear. But you can imagine that it could be a disaster if you don't realise that you've got the crank web touching this jaw and you crank it up tight to bend the whole crankshaft. Well, that's essentially the driving end of the crankshaft. So any pulleys or accessories that you put on the engine would go on this end, and this other end is where the flywheel is going to go. So I'll shorten this off camera, and then we can put the keyway in for the flywheel. So here's the setup for doing the keyway in the crankshaft. So I've set the webs of the crankshaft vertical using a DTI. I use touch DRO to find the center of the vice jaws and the edge of the crankshaft end. And we've got a 2mm carbide end mill, and we're going 7/8 of an inch long and 1/16 of an inch deep. Sorry about the mixed units, but you've got to use some proper metric measurements occasionally. And yeah, it's a tiny cutter, brittle cutter. What could go wrong? It left a pretty nasty burr, but I'll stone that off. It should be fine. Okay, let me see if I can explain the setup that I'll be using to cut the tapered keyway in this little model flywheel. Now, I did some research, and it turns out that tapered gib keys have a standard slope of around about 1 in 100. Now, when you draw that out in CAD, which is what I've done here, it turns out that the angle that you need is around about 0.57 of a degree. So I've set this fixture plate in the vise here at an angle of 0.6. That's as close as I can get with this little angle gauge here. Okay, the next thing is I have a specially ground cutter which I'll show you in a close-up in a minute. I've got this set up in a collet and I've swept the side of the cutter here, and I think I've got that set so it's parallel to the y-axis. So it's really awkward to set up because it has some rake at the bottom, some clearance, but this section here where I'm actually putting the probe on, there's no back rake on that, no back clearance, so I think I've got that right. So there's a close-up of the cutter that I'll be using here, and this is ground from a 6mm high-speed steel blank, and I did this on my D-bit grinder. So it's got some clearance underneath here, and it's got a bit of back clearance on the cutting edge here. The cutting edge itself is 2mm thick, which suits the keyway that goes in the crankshaft. And I've got some key steel, which is also 2mm. Now, previously I've set up the spindle directly over the center of the bore in the flywheel, so I can return to that spot with the DRO, and then we're just going to advance across and take the cut down through the bore of the flywheel. Now, I tried this out on some scrap cast iron and it works quite well, but you've got to go very, very steadily. This cutter is very slender, and I imagine if it jams up or if you overload it, it'll just snap. Well, that was hardly worth getting excited about. That's 1/16 of an inch deep on the outside of the flywheel. It'll be narrower on the inside, but that's enough to get our key locked to the crankshaft. Now, that's the stock that I'll be using to make the key. This is actually an old roofing square that I had to cut to make shorter, and I've machined that on both sides so that it's 2mm thick, and I've decked the top there so that that's an accurate surface. And before I break this setup down, I'll clamp a small vise to the fixture plate, and I'll machine the top of the key to the correct angle, the same angle as the fixture plate. Okay, in theory that gives me the correct taper on this top edge here in relation to the end of the stock. And what I'm going to do is make a key out of sheet metal first, so I'll just check all of the dimensions, get the profile right, and then I can cut the remainder of the key from the stock underneath here. Okay, after a lot of messing around, I was able to make a key from some thin brass stock here. Now, I went through several iterations of dimensions on this, and even now, after doing a CAD drawing, I'm still going to have to adjust some of the dimensions, but this key now fits, and I'm ready to go ahead and make one out of steel. I'll just show you how it fits. Okay, if you align the two keyways there, you can slide the little brass key in there, and there will be an extension of the crankshaft past the end boss of the flywheel later on of about 1/8 of an inch. And I can tap that key in there, but I'm a bit reluctant to tap it in too far because it is very hard to get out. So as that taps in and it seats, that pretty much locks the flywheel to the crankshaft, so I'm quite happy with that. I'll go ahead and make one out of steel. It will need some minor adjustment to get that to align the head of the key with the end of the crankshaft, which is basically what I want. But we'll go over to the mill now and we'll make the steel one. Right, well, there's our brass key in front, and you can see the profile we've got there, and this slope on top here is the correct slope of 1 in 100. The head of the key will be over here, and all I need to do now is mark off a line parallel to the bottom edge of the sheet stock and hacksaw that to shape, and then finish by filing. But that's the hard part. There's a lot of backwards and forwards and fitting and trying the key until you get it to slide in correctly. So to mark out this line, I've actually set my height gauge to the top of the slope. So this is the thickest end of the key, and according to the brass one that I made, I need to offset below that 3.18. I've actually set the height gauge to 3.2, and that will give me a tiny bit of filing allowance. The thing is with these keys is that you file a micron off the height of the key and it will slide 100 microns further in. So there's not much room for error. So I'll go ahead and scribe this, and then the other trick is you've got to hacksaw it out to that line. Alright, you probably couldn't see that, but there's my scribe line, but I will hacksaw this out wearing a Mr. Pete style magnifying visor. Just using one of these fine-tooth junior hacksaws to do this. It's a bit tedious, so I'll bring it back when I'm done. Oh, there it is. I can still see the scribe line, so I'm just going to have to keep working at this very, very slowly now. Just cross-filing, then draw-filing, and just keep trying it. Wish me luck. Okay, it's time to machine the cylinder for the engine now. And what I've done here is I've just cleaned up both ends and the top face on the belt sander, and I blued up that top face there, and I've scribed off some marks on that top face. Now on the drawings it shows it's 1/2 inch from the edge of the exhaust port in the center to where the end of the cylinder casting will be. So that's what those scribe marks are for, and I'm going to hold this part on a turned aluminium spigot. Now it's been machined to fit inside the bore, and it's just a cord hole, so it's not going to be totally accurate. But with that sitting on that spigot now, you can run that up into the 4-jaw chuck, and you can close the jaws and know that the cord hole is going to be running more or less concentric with the axis of the lathe. So of course I've already done this, just so I get the jaws fairly close. So you just run the jaw until you feel it make contact. And then just put some moderate pressure on this. So what we're going to do from this end is we're going to face it off back to that scribe mark and then bore it out. And then we can flip it around and put it on another mandrel to machine the other end. Then, knowing that we've got the bore and the two end faces square to each other and accurate, we can clean up the top face. It's cleaned up to that mark now, and you're probably looking at the bore there and saying, well, that's not running true. But with the tip of the tool against this circular face around the outside of the casting there, I can spin that around, and it's tracking that circular edge fairly closely. So the actual position of the bore at the moment is not that important. Later on, when we go to machine the port face, that's when we need to offset exactly from the center of the bore to that port face. Okay, that's about 0.11 to go, 0.1 millimeters. And I don't have a 3/4 inch reamer, so we're going to have to get this finished straight off the tool. And I'm using a high-speed steel boring bar, and I've honed that, and it's got a reasonable sort of nose radius on the tool, and it's leaving quite a nice finish, so I think that's going to be fine. (1904). It's meant to be 1905. I've got to machine the piston into fit, so I'll leave it there. I can always lap that, but I think that's overdoing it. Well, there it is. I'm pretty happy with the finish. I'm going to make up a spigot and put it in the 3-jaw chuck, and I'll just super glue this to the spigot so we can finish the other end. Okay, cylinder's the right length. What we need to do is get this off here now, get over the mill and clean off the port face. I'm just getting ready to machine this top surface of the cylinder. This is going to be the valve face, if you like, where the steam chest bolts on. And I've made up an aluminium spigot that fits in the bore of the cylinder. Now this exposed end here is 24 millimeters diameter, and the bore is 3/4 inch or 19.05. Now I'll be using that same aluminium spigot later on as a device for holding the cylinder so I can drill the stud pattern on the two ends. But for the moment I've been able to touch off on both sides of that aluminium plug there, and then center find directly over the center of that in X. And I also touched off with the cutter on the top of that surface there and zeroed Z. So then I can make sure I finish at the correct height above the center of the bore. Now I've also put a digital angle gauge on that surface there, and I've tapped that until it reads 0. Now this is just a rough casting here. I've sort of given it a bit of a sand, but it's not going to be terribly accurate, but that's relatively flat there. Now in Touch DRO I've also marked off the 4 positions where the studs will go, and I've saved that as a subdatum so I can go back later on and find those same positions on the steam chest and the steam chest cover. So I'll go ahead now and clean that off, and then I'll drill the holes. I'll give that a rub later on some emery cloth just to give it a uniform finish. But we'll get these corner holes drilled now. Oh, missed a bit. That's better. I'm just about to machine these steam ports in the barrel face now. I'm using a 2mm carbide end mill. The drawing actually calls for a 5/64 end mill, which is 1.98mm, and I'm using 2. I don't have a 5/64, so I think I'll get away with that. And I've got a whole heap of points set up in touch DRO, and I'll show you those in a minute. And all I need to do with the 2 steam ports, which are the ones on the outside, is to plunge down to the correct depth, machine across and come back up again. But the exhaust port, which is the wider one in the centre, I'll need to go in at 4 points and machine both sides. But I'll show you on touch DRO what I've got set up. So here is my point list on the right hand side, and I've got the spindle directly over the corner of the seam port on the top left hand corner, and I'll need to come across this point, come back up again, and as I come across, this digital display here will shift to 0 as I reach that point. And for the exhaust port, I've got 4 points plus a centre. Alright, I think you get the idea there. I've got to go deeper for that exhaust port. It's got to be 5.56, I've only gone 2, but I'll bring it back when I'm done. Alright, well there's the steam and exhaust ports cut. What I need to do now is drill a hole in the side of the casting for the exhaust port and also the 2 drain valves. Alright, that takes care of all the holes in the side of the cylinder. We need to do the mounting holes to the top and bottom cover now, and I'm going to use the same spigot for doing that. I put that same spigot that was inside the cylinder in a square collar block, and I've set that to 0 under the spindle. So I've zeroed out the DRO, and I can put the cylinder back on that spigot now and work out the stud pattern and drill all the holes. So the cylinder fits over that, and I'm going to use a big washer to hold it down, and then I'll align the port face with either X or Y and work out the stud pattern position according to that face there. I'll get a 7BA tap in all those holes there, you don't need to see that, and the other end is the same, so I'll get on and do that off camera. Well, there's the cylinder with all the holes drilled in it, apart from the holes that connect the end of the cylinder to the steam chest port. So I need to set this up on an angle to be able to drill those holes. Just going to quickly knock up the bottom cover for the cylinder. I'll do the top cover too. A lot of this is just plain turning, so I'm just going to rush through it. I'll drill all the holes and we'll assemble the cylinder and mount that to the rest of the engine I've already made. So stand by, it's going to be a rush job. If you're wondering what this gadget is here, this is called a flexi chuck. It's made by Eccentric Engineering, and these jaws here are soft aluminium jaws. You can machine those, you can bore them out, you can make spigots on them, you can drill holes in them. And when you crank the Allen key in this socket head screw here, it expands the jaws, so you can load a part and then collapse them again, or you can do the opposite. Put a ring over a spigot, expand the jaws and hold it. Yeah, they're great. Not sponsored. Okay, the top cylinder cover's the same, got the same pitch circle diameter, same number of holes, same diameter, so I'll do that off camera and then we'll put the cylinder together. Hey, and it lines up, yay! Well, here's the engine assembled to this point. Now I haven't put all the fasteners in yet because you've got to take it apart like 100 times as you're making new parts. So I've just put in enough to hold it together at this point. But it's all turning over really nicely. Everything's aligned correctly. Everything seems to fit well. And I know what you're thinking. You're saying, hang on, what happened to the key that you're going to use for this flywheel? Where is it? Well, I'll turn it around and let you have a look. So there it is there. Now the thing is, it's oversized. I haven't done all the finishing on this yet, and I certainly haven't hammered that in as far as it will go, because trust me, it's really hard to get out again. You've got to grip that with a pair of pliers and really wriggle that out. The actual step in the gib head is probably too small to make a tool to reliably remove that key without damaging something. So I'm going to leave that right to the end, and then I'll tap that in, and that will lock the flywheel to the shaft. Now you're probably also saying, does the flywheel still run true? And the answer is, well, almost. It's got a tiny amount of run out, and I think that's because the key is not shaped exactly right. And when you tap it in, it can ride either on the outside of the flywheel or the inside of the boss, and that has the effect of kinking the flywheel over, so the axis is no longer aligned. But again, I think I can trim that and do a bit of work on that to fit it. But that's going to happen right at the end. Now, in the next episode, I'm going to go ahead and I'm going to make the steam chest and the steam chest cover. So there's the steam chest casting. It's rough all over. It does need a lot of machining. And this is the steam chest cover. Now, I had a bit of a look at the drawings, and I realized that when you fit this steam chest, it's lying horizontally, and the cover is also going to lie horizontally, which puts that letter S on its side. Now to me that's totally unacceptable. I couldn't stand that. So I'm going to have to work out a way of either making a whole new steam chest cover out of cast iron, which is going to be difficult, or I'll do something about removing that letter S from the center and making some sort of a brass feature that goes back in its place, but that'll be coming up. Now the slide valve is pretty much fully finished. You don't need to do much to that at all. So that's just a case of giving it a light file and cleaning up the face, making sure it's flat, and getting some threads on the end of this rod here. So that'll be in the next episode, and I'll also drill the holes in the cylinder which connect the bore to the ports on the side here. So all that coming up, so join me for that. I'm going to leave you today with some footage of some birds that we saw around a tree that's flowering in our yard. Now this tree is quite a large rainforest tree. It's called a golden pender, and it only flowers probably every 4 or 5 years in our yard, and this year it's come out in this beautiful crop of flowers, and it's attracted some rainbow lorikeets and some blue-faced honeyeaters. So we'll have a look at those, and then I'll sign off and I'll see you next time. Okay, it's Prezzo. Cheers.